Hello students. In this video we will address hypothesis test type of questions. So we're going to work out how to understand the question, how to understand the process in order to develop the calculations required to come up with the correct answer. So to help us understand the process of and what is an hypothesis test, we're going to use question 1 and the review questions from your course package. So in this example, a consumer purchases a new light bulb advertised to last at least 1,000 hours. The consumer believes the light bulb doesn't live up to the claim, so he tested 40 light bulbs and found the average life was 950 hours. The population standard deviation is known to be 100 hours. So a couple questions we can answer is this a one or two-tailed test? And then at the 1% level of significance, are the light bulbs different than, significantly less than the manufacturer's claim? So let's work this out to understand what hypothesis test type questions are actually getting at. So let's draw standard normal distribution. So for this example, the claim is that the average light bulb lasts 1,000 hours, at least 1,000 hours. So the consumer takes a sample of 40 light bulbs, turns them on, and just waits until they die out, and tabulates the time it takes for each light bulb to die out. He finds that on average, the light bulbs last 950 hours. So, hypothesis test, this is the claim. Average is 1,000 hours. The hypothesis is that they will last at least 1,000 hours. So the consumer is going to be concerned about the idea that they last less than 1,000 hours. So what would happen if he takes a sample and he finds that the average length is right there? Average time of a light bulb is, say, 995 hours. Could he go to the manufacturer and cause them to change their advertising based on that sample data? Probably not, because it's really close. We have to remember something about sampling. Samples, basically in a sampling process, basically not 100% accurate. As we talked about in our sampling section, as well as our confidence intervals. Sampling, not 100% accurate. The idea is, what's the probability that we are close enough to that value? So let's go back to this example. So the consumer found that the average was down here, maybe 980 hours. Once again, could he go to the manufacturer, cause them to change their advertising or promotion, or even sue them because they're not living up to their claim? Probably not. Now what if he found that the average was way down at that far extreme, say like 700 hours? He may have justification to approach some type of consumer group and say that this manufacturer is falsifying their advertisements, misleading the public, or whatever, because we don't want to have light bulbs not living up to their claim. So there becomes, when we look at on the left side of the distribution, over here, probably close enough. Somewhere over here, probably not close enough. So we have a point at which we would be kind of okay with that value. So if the averages were like even down here or down here, we're probably saying, well, geez, it's kind of close enough, given that sampling is not 100% accurate. But if the averages were way down here, we probably have enough evidence to go and go to this manufacturer and press our claim. So as we've said, there is this threshold value. This threshold value we're going to call a critical value. and we denote that critical value as a Z value, Z alpha, or T alpha for hypothesis tests on the mean or the proportion. This Z alpha or T alpha is that threshold or that point at which basically anything up here, we're going to basically say that the manufacturer's claim is kind of okay. Anything on the slower end, anything down here, basically not okay. It just shouldn't happen. We understand the laws of probability and normal distribution that anything over in this area has such a small chance of occurring that when it does occur, something is wrong with it, the claim that the manufacturer makes. You know, this claim right here that the average is 1,000 hours. So that is the process of what we do in hypothesis testing. Now, in order to carry out this hypothesis test further, we need to collect the data, as this consumer did. This consumer found that on average the light bulbs lasted 950 hours. He tested 40 light bulbs, and this population standard deviation is known to be 100 hours. Because the population standard deviation is known, we can use a Z value. So that's where our critical value comes in. If the population standard deviation was not known, we would have to use the sample standard deviation, and then we'd have to use the T value, the critical value for T instead of Z. So let's work through this process. Let's find some more room. In the question, it states what the critical value is going to be. The critical value, let's write that up here. Critical value is basically a Z alpha or a T alpha value. Z, if we know the population standard deviation, if that is known, or for T, basically if the population standard deviation is not known. So in this question, we are given the population standard deviation. Population standard deviation is known to be 100. We are also told what the critical value is going to be based on. Critical value is based on a level of significance. In this case, alpha is stated to be 0.01. So now from that, we can find our critical value, that threshold value. We can find that by looking at our T distribution value, because we know that the bottom row contains Z values. We're going to be using a Z value because we are given the population standard deviation. So one thing we need to answer first is question part A here. Is this a one or two-tailed test? Keywords in here, right in there, at least. At least means that the claim is 1,000 hours or more. We're going to be testing to see if the sample data is less than that. So this is a one-tailed test. So we know that it's, and there's keywords you need to look for in the question as specified in the course package under this section. So we know that this is a one-tailed test because of the keywords. We also know that alpha is, as I said, 0.01. So let's write out what we have so far in terms of the actual process or steps needed to solve this hypothesis test. So the hypothesis test is a statement. The statement is that on average the light bulbs last a certain amount of hours. So HO is written as the null hypothesis or the manufacturer's claim. So that is a null hypothesis. That is the manufacturer's claim. They claim that the light bulbs last at least 1,000 hours. We are going to test the opposite. So alternate hypotheses is written as the two hypotheses are mutually exclusive. So if one is greater than, the other one has to be less than. If one is less, if one, the null hypothesis is equal to, this would be not equal to. If the null hypothesis is written like this, the alternate hypotheses would be written in that format. We also know that this is a one-tailed test that is needed to find the critical value, which is a Z value. The critical value is going to be negative because right in there, that symbol, it's pointing to the left, basically mean that we are testing to see if it is less than average. Less than average means a negative Z value. So go and find the critical value for Z. Look at your t-distribution chart. Alpha is 1%, right in here. It's a one-tailed test, so we do not have to divide it by 2. We only divide alpha by 2 for confidence intervals, or for what we refer to as a two-tailed hypothesis test. So our critical value is going to be 2.33 right at the bottom. So let's write that in there, 2.33. So the next process or step in the hypothesis test is to calculate a test statistic. So the value that we need to calculate is called a test statistic, different than this value here. This one, as you recall, is called a critical value. So in a hypothesis test, we finish up with two values that we compare to. So getting back to this test statistic, it is another Z value. If we had a critical value that was based on a t value, our test statistic would be a t value. So you always have either two Z values or two t values. So we're working with our Z value. The formula, same formula we've seen before. We substitute in our values. 950 is our sample mean, 1000 is the population mean. That's right from our null hypotheses. Standard deviation is 100, right from the question. And we are dividing by the square root of our sample size, square root of 40. So we end up with a test statistic of a value of negative 3.16. So in a hypothesis test, we are comparing the test statistic to the critical value. If the test statistic is more extreme than the critical value, has a larger absolute value than a critical value, we are going to make this decision to reject the null hypotheses. Rejecting the null hypotheses basically means we can scratch that null hypothesis out because we have proved that it is not valid. So we are left with the statement that the average life of a light bulb is not 1,000 hours. The decision to reject our null hypotheses is based on this process. Let's just get some more room here. It's based on this process where we reject the null hypotheses if the test statistic is greater than the critical value. So even though our value was negative 3.16 for the test statistic and our Z value was negative 2.33, if you remember to make those values absolute in making the decision, you can easily make the decision to reject the null hypotheses. The opposite statement, if the test statistic is not greater than the critical value, we are left with this statement. We cannot reject it, or you have failed to reject the null hypotheses. So those are the only two statements you can make. Either to reject the null hypotheses or we cannot reject the null hypotheses.